Imagine a force powerful enough to darken the skies and shroud the Earth in a chilling volcanic winter. Picture ash clouds spreading across continents, halting air travel and choking the air we breathe. This is not a scene from a science fiction film, but a stark reminder of the immense power slumbering beneath our feet. Supervolcanoes. These geological giants, capable of eruptions thousands of times larger than anything witnessed in human history, are a testament to the raw, untamed energy that resides within our planet. While most lie dormant, their potential for destruction is a sobering reality. The discovery of potential activity within one such supervolcano, hidden within the Earth's largest caldera, has sent ripples of concern through the scientific community and beyond. The question is not if it will erupt, but when. The answer may lie hidden deep within the Earth, but the consequences of its awakening will be felt globally. This is not a time for fear, but for understanding and preparedness. By unraveling the secrets of these colossal forces, we can hope to mitigate the risks they pose and ensure the safety of our planet and future generations. The time to act is now, while the giant still slumbers. To grasp the sheer scale of a supervolcanic eruption, we must first understand the colossal structures they leave behind, calderas. Unlike traditional volcanic cones, calderas are immense cauldron-like depressions, often spanning dozens of kilometers across. These gaping wounds in the Earth's crust are not formed by explosive outward eruptions, but rather by catastrophic inward collapses. Picture a vast magma chamber miles beneath the surface, filled with molten rock under immense pressure. As this volatile reservoir strains against the Earth's crust, it creates bulges and cracks, releasing pressure in the form of gas and molten rock. These initial eruptions, while significant, are merely a prelude to the main event. As the magma chamber empties, the support structure weakens, leaving the overlying landmass vulnerable. The result is a cataclysmic collapse, as billions of tons of rock plummet into the emptied chamber, creating the characteristic caldera depression. These scars on the Earth's surface serve as a stark reminder of the devastating power that lies beneath. These silent giants, often hidden in plain sight, are a testament to the Earth's raw power and a constant reminder of the forces that have shaped our planet over millennia. The Earth, much like any living organism, communicates through subtle cues and tremors. When it comes to supervolcanoes, these whispers can manifest as unsettling signs of unrest, hinting at the immense power brewing beneath the surface. Recent scientific observations have detected a series of such anomalies within the world's largest caldera, raising concerns of a potential reawakening. One of the most alarming indicators is ground deformation. Using advanced satellite technology, scientists have observed subtle but significant changes in the elevation of the caldera floor. These uplifts and subsidences, often measured in centimeters per year, suggest that the magma chamber below is experiencing pressure changes, potentially indicating a recharge of molten rock. Furthering these concerns are changes in gas emissions. Volcanoes, even in their dormant states, constantly release gases like sulfur dioxide and carbon dioxide. An increase in the volume or a change in the composition of these emissions can signal a shift in the magmatic system, potentially indicating the rise of magma towards the surface. Finally, seismic activity serves as a crucial indicator of a volcano's internal state. An increase in the frequency or intensity of earthquakes beneath a caldera can suggest the movement of magma, fracturing rock, and increasing pressure within the system. While a single earthquake might not be cause for alarm, a swarm of seismic activity could be a warning sign of an impending eruption. The eruption of a supervolcano is not merely a local disaster. It's a global cataclysm with the potential to impact every corner of our planet. The sheer scale of such an event dwarfs anything witnessed in human history, with consequences far exceeding those of even the most powerful volcanic eruptions in recent memory. One of the most immediate and widespread impacts would be the sheer volume of ash ejected into the atmosphere. Unlike the localized ashfalls from smaller eruptions, a supervolcanic blast could blanket entire continents in a thick layer of ash, collapsing roofs, clogging infrastructure, and disrupting transportation networks. Air travel, grounded by the abrasive ash particles, would come to a standstill, severing global connections. Beyond the immediate physical impacts, the long-term consequences on the global climate are even more concerning. The massive ash cloud, laden with sulfur dioxide, would act as a global dimmer switch, reflecting sunlight back into space and triggering a period of dramatic cooling known as a volcanic winter. This prolonged period of reduced sunlight and lower temperatures could devastate agriculture, leading to widespread crop failures and food shortages. The health impacts of a supervolcanic eruption are equally alarming. The fine ash particles, easily inhaled deep into the lungs, can exacerbate respiratory illnesses and pose significant risks to vulnerable populations. Furthermore, the contamination of water sources and the disruption of essential services would lead to widespread health crises, requiring a coordinated global response. In the face of such a colossal threat, knowledge is our greatest defense. Leading the charge in monitoring the world's largest caldera is NASA, leveraging its expertise in space technology and Earth observation to provide crucial data and insights into the volcano's behavior. One of NASA's key assets is its fleet of Earth-observing satellites, equipped with a suite of instruments capable of detecting even the slightest changes in the Earth's surface. Using a technique called interferometric synthetic aperture radar, or INSAR, these satellites can measure ground deformation with millimeter-level precision, allowing scientists to track the subtle swelling and subsidence of the caldera floor. Beyond ground deformation, NASA instruments can also monitor gas emissions from space. Instruments like the Atmospheric Infrared Sounder, or AIRs, can measure the concentration of various gases in the atmosphere, including sulfur dioxide and carbon dioxide, providing valuable insights into the magmatic processes occurring beneath the surface. Furthermore, NASA's expertise in data analysis and modeling plays a crucial role in understanding the potential impacts of an eruption. By combining ground-based data with satellite observations and sophisticated computer models, scientists can simulate the spread of ash clouds, predict climate impacts, and assess the potential risks to various regions, allowing for better preparedness and disaster mitigation strategies. The potential reawakening of a supervolcano is not a localized concern, but a global challenge demanding a coordinated and proactive response. Preparedness, both on a national and international level, is paramount in mitigating the potentially catastrophic impacts of such an event. One crucial aspect of preparedness is the establishment of robust early warning systems. By leveraging real-time monitoring data from NASA and other scientific institutions, we can develop sophisticated systems capable of detecting and interpreting the warning signs of an impending eruption. These systems, coupled with effective communication channels, can provide crucial time for evacuation, resource mobilization, and the implementation of protective measures. Beyond early warning, preparedness requires a comprehensive approach that addresses the multifaceted challenges posed by a supervolcanic eruption. This includes developing strategies for ashfall mitigation, ensuring food security, and securing critical infrastructure. International cooperation, information sharing, and the coordination of resources will be crucial in effectively responding to such a global crisis. Investing in scientific research is equally crucial. By deepening our understanding of volcanic processes, improving monitoring techniques, and developing innovative mitigation strategies, we can better equip ourselves to face this looming threat. This requires sustained funding for scientific institutions, international collaboration among researchers, and a commitment to advancing our knowledge of these powerful geological forces. While the prospect of a supervolcanic eruption is daunting, it's crucial to remember that fear must be met with knowledge and action. The more we understand about these colossal events, the better equipped we'll be to predict, prepare for, and potentially even mitigate their impacts. Scientific research remains our most potent tool in this endeavor. By delving deeper into the intricate workings of volcanoes, we can unravel the mysteries surrounding their eruption cycles, magma behavior, and the factors that contribute to their awakening. This knowledge is essential for refining our monitoring techniques, developing more accurate forecasting models, and ultimately enhancing our ability to anticipate and prepare for future events. One promising avenue of research involves studying the geological records of past super-eruptions. By analyzing the layers of ash and rock deposited by these ancient events, scientists can glean invaluable insights into their magnitude, frequency, and potential impacts. These insights can then be used to refine our understanding of the risks posed by present-day supervolcanoes and inform our preparedness strategies. Another crucial area of research focuses on developing innovative technologies for monitoring and potentially even mitigating the impacts of super eruptions. This includes exploring novel methods for early detection, such as analyzing subtle changes in Earth's gravity field or detecting precursory gas emissions. Additionally, researchers are investigating the feasibility of harnessing geothermal energy from supervolcanoes, which could potentially help to reduce pressure within the magma chamber and mitigate the risk of a catastrophic eruption. The potential reawakening of a supervolcano serves as a stark reminder of the immense power that slumbers beneath our feet and underscores the importance of scientific understanding and global cooperation in the face of existential threats. This is not a time for complacency, but a call to action urging us to confront this challenge head-on. We must champion scientific literacy and empower future generations with the knowledge and tools to address this challenge. By fostering a passion for STEM education, supporting scientific research, and promoting evidence-based decision-making, we can cultivate a society equipped to navigate the complexities of our planet and ensure a safer future. The threat posed by supervolcanoes transcends national borders, demanding a unified global response. International collaboration, information sharing, and the pooling of resources are essential for effective monitoring, preparedness, and disaster response. The Earth has provided us with a precious gift, a planet teeming with life, wonder, and endless possibilities. It's our collective responsibility to safeguard this gift for future generations. By embracing science, fostering collaboration, and acting with a shared sense of urgency, we can face the challenges ahead with courage, ingenuity, and a steadfast commitment to protecting our planet, our home. The time to act is now, while the giant still slumbers.